Okay guys, pointer there, computer here, audience over there. Everyone understands English. You can switch to French if it gets too slow. So, the office was founded in Paris in 2009 by Thibault and Pressacco. Today a team of 20 collaborators are involved in construction, teaching and research, awareness of the soil and the architectural future of the resources it contains. Necessary balance between belonging to the context and the autonomy of form, the use of materials and the order in which they are assembled, the need for something new in relation to the major dogmas of the discipline. These are some of the vectors that frame the production of the office. Driven by this movement from practice to research and back to practice again, we are currently carrying out studies for the construction of France's first 50-meter high building in solid load-bearing stone and Hempcrete. Hempcrete means Swedish. Oh, wonderful. Okay, it will take 30 minutes for us to understand what is hempcrete, but the floor is yours, please.
Thank you very much.
Yes, thank you. I'm Thomas, and this is Thibault Barrault. And yeah, we've been working together at the Barrault Pressacco for several years now. Yeah. Working a lot around questions of materiality, of construction, and of technique. And I guess there was already a sort of general overview about what we're looking at the agency, but I think what I'd like to do is just take a couple of minutes to talk to you about what we would like to present to you today, which is an idea, a word, fullness, which is an idea that we've been thinking about a lot at the agency for the last few years. And it's a word that for us holds a huge amount of potential for the architecture that we're working on and what we would like to be working on in the future. And it's a potential which is related to the materials that we build with, the way that we're building, but also the kinds of spaces that we're creating, the way that we're theorizing architecture today. And this idea of fullness, we're really talking about sort of massivity, of thickness of materials in the architecture that we're drawing. And so we're going to talk to you today about this idea of fullness through two materials that we work with a lot at the agency. So it's massive load-bearing limestone and hempcrete. So hempcrete, which is hemp, the plant, which is mixed with lime, and which together create an insulating material. And so when we're talking about this idea of fullness, obviously it's part of a great tradition of architectural construction, where we're building with massive materials, which originally, of course, was out of necessity. And this sort of exploration of a massive architecture, of a very full architecture, was really brought into question in the 19th century, early 20th century, out of questions of economy of means, where we started to really question the amount of materials that we were building with, the types of materials that we were building with, and the space that they occupied in our constructions. But what we find really interesting is that this idea of massivity, of fullness, when we start considering it very closely, we very quickly overcome only a sort of constructive point of view. Because when we start considering fullness, we're looking at it, and we see that it's a question about representation. So of course, this great tradition of the Beaux-Arts school, where we're looking at poché. I don't know if this is the same word in Estonian, but it's this tradition of representing the architectural drawing by filling the contours of what's defining the built space. And when we start looking at these questions of representation, obviously it changes the way that we're conceiving of the architectural project. And this is what we see in the work of Lewis Kahn in his studies of the Scottish castles, is that when we start really considering the pocher and the fullness of the architecture, it takes on actually a spatial quality, and we start looking at the fullness of a structure as being capable of taking on the dimension of a room, of the connection between rooms, and it's this sort of starting point, these questions which emerge from the consideration of fullness, that we find very interesting and exciting today. And we find that exciting because what we've noticed with working with natural materials over the last few years is that when we're working with natural materials, and when we're working in the current environmental and climatic crisis within which we find ourselves today, architects are really driven towards considering the thickness, the fullness of the buildings that we're creating, and particularly in relation to the facade, which is this interface between indoor and outdoor. And when we are working with natural-based materials, so when we're working with stone, when we're working with hemp, with straw, with all kinds of bio-based and geo-based materials, we can no longer manipulate the very fine thickness, maybe that we've been used to manipulating over the last 50 years. These are materials that require a much larger dimension, and we think that this fullness, this very large dimension, is interesting to consider. Is interesting to consider in the architectural project, and we want to present this concept sort of in opposition with this prototype of architecture, the Maison Domino, which has really come to define a sort of extreme efficiency in the way that we build, which goes so far as to completely dissolve the facade. And we think that today this is really problematic, and we can't continue to build with this image of a facadeless building. That we need to consider the way that we treat the envelope of our constructions in a new way.
And so in addition to this, let's say that this diagram, when we took this drawing made by Le Corbusier in 1918, the problem is there that the thickness is totally abandoned, let's say, so that prototypes were considering, and let's say it was a beginning of an interpretation that was hoping that there would never ever be any kind of separation between the inside and the outside. And what we like to investigate today, like Heather was saying, is what if we were giving another interpretation to that? And what if today this ossature domino was still a good prototype to look at, but let's give it another direction, another trajectory. So it's not like killing modernity in its efficiency, its economy, but rather looking at modernity as something that has other a story to tell, let's say. And it's funny because in the project we will be talking about today, we realized yesterday with Heather that they all start somehow with this prototype of ossature domino. So this is the building that we made in Rue Borkampf, that we delivered in a bit more than 6 years ago now. So the relation with the ossature domino, let's say, is kind of obvious because you can see in the first plan this steel ossature that is bearing the wood panel, the floors, the wood floors, and at the end you can see the load-bearing stone facade. And it's the first time we look at this building and we present the building from the inside, saying that one problem, let's say one issue with natural materials is the fact that they never come alone, let's say. They always are assembled to other materiality, other materials, and when you say that you build with stones, it's not really correct. Let's say that 20% of the building is in stones, but all the rest is, technical things, shafts, steel, wood, as natural as possible, but not everything is natural. And we're very interested in this idea of natural resources, that at some point you have to negotiate when you build a building with other, resources that are all geo-based resources, but they don't raise the same amount of energy coming from a resource to an element of architecture. So we have to be aware that building with natural materials is still a negotiation between different trajectories. So then we look at the outside of the building this time, and you can see so the load-bearing stone facade that is getting the loads from the floors, and it is articulating two aspects of the two traditions that exist in Paris. On the right side, you can see this Faubourian, very poor, very dry building, and on the left side, the more bourgeois Haussmannian style building. And our building is trying to articulate these two periods, these two moments of Paris through the load-bearing stones, of course, but also with this idea of the window that is something very important in the Persian tradition. So this is the resource itself. So what is incredible when you build with stones is this relation you start having with the ground, with the earth, the telluric aspect of the earth. So this is something that changed, let's say, our minds as architects when we started encountering, let's say, this kind of environment. So we were digging into the ground and realizing that there is something in between the moment stone is a resource and another moment where it's been digging out of the ground and it starts being an element of architecture in your mind. And what is great here with this natural resource is the very few amount of energy that exists between the moment where it is the ground and the moment where it is an element of architecture. So the very low energy engaged in the transformation, the very few displacements, all the very, very few gestures that you apply to the resource, and then it becomes an element. So this is a zoom of the window where you can see that the cut of the lintel is the only, let's say, gesture that we allow to ourselves to express somehow the modenature and the tradition, and to, let's say, appertain to this tradition of the Persian facade, Persian window, let's say. And with this very small cut, which is the only tool that you have when you build with stones, is this moment of the saw, you cut, you extract, and we just gave a small angle to the lintel to express, let's say, this idea of the lintel becoming a facade, etc., etc. So that's the plan. To the picture were taken from here, the first picture of the site from here. So you can see the two alignments of steel structure. And then from here, this is the inside courtyard. And again, we are very interested in applying to the stones other elements such as concrete to kind of conturn or to escape from this war between stone and concrete, which always has been profitable to the cement, let's say. So we kind of stay out of the debate and rather defend the idea that stone has to be more and more important in the, let's say, building industry. But cement will always be here for sometimes good reasons, let's say. And we're very interested in the way they negotiate together and how cement gives to the stone some actuality, some contemporaneity, let's say. So we use it as lintels in this part of the building, so in the inner courtyard, to give to the living rooms bigger openings on the outside. And we draw, just like the drawing Heather was talking about at the beginning, drawing the building is something that we do a lot, drawing the construction details to always express that we need to represent the detail, the construction, how things come together, how they negotiate together, and how through this assemblage we give to any kind of element constituted of the assemblage a power to participate, let's say, to the architectural language. And this is the drawing and the fascination we have for drawings that gives us, let's say, this availability to understand the position of each object, just like Choisy we were talking about at the beginning. From the outside again, so you can see the relation between the concrete, the basement, and the facade. So let's say that we're keen on showing that we have concrete underneath, so we like to say that concrete goes a little up, and that it defines a ground floor for the building, and then get the loads from the facade. Another drawing that shows this facade, so you can see, like we said, the relation between the load-bearing facade. You have a steel element here, and then the floor, the wood floor, giving its load to the load-bearing facade. And then we scaled up a little bit, so from the very same kind of constructive system from Röberkampf. We won this competition 3 years ago now, so site will hopefully begin at the end of this year. But it's exactly the same, let's say, principle. So you have concrete on the basement that links two levels of the city, one high level and one lower level here, and then the load-bearing facade upstairs. So we have there different kind of stones. We have like hard stones, getting more loads, of course, and then a little softer stones on top of the building. And again, this idea of hybridization. Sorry. So we still have a little concrete in blue, and then the floor wood paneling green, and then the stone orange on the outside. So it's always like this, always like this, always like, okay, what is the best material, how we can profit from its all advantages, and how they all create this kind of hybrid system, like a cathedral, you know, but not only with stones, with all the materials that we have in our possession. That's the plan, but what is interesting in the plan is the measures of the rooms that gives us, you know, the measure of the construction. So you have the concrete here, the stone, the columns. So again, this idea for Central Domino, you know, they're very punctual structure inside the building. Then we have the wood in green there, then steel beams, and then the load-bearing facades with this time concrete lintel to have like bigger openings on the facade. Then a view of the model.
And so this first project we're looking at is looking at, you know, thickness from a sort of a very massive, maybe a structural and a gravitational point of view. This is another project where we're looking at this idea from a more thermal point of view. So this is an operation of social housing that we completed maybe four years ago? Yeah. 2 years ago. 2 years ago. 2 years ago. and it uses a hempcrete facade, so this mixture of hemp and lime, and it's looking at the facade as an element of thickness, technically thick for thermal reasons, but also that starts to explore the spatiality of what a very deep facade can offer in terms of spaces. And so again, we find this relation with the Maison Domino. So we're not in any way trying to deny the efficacy, the efficiency of this structural system, but questioning the way that we can make it even more efficient, even better adapted to current conditions and requirements. And so here we see the system of the facade. So we have the concrete internal structure, a secondary timber framework within which we project the hempcrete mixture. The hempcrete attaches itself to this timber framework, and then a render finish on the exterior part of the building. And so again, this is the resource that we're working with. So it's the hemp plant, and this is it's a really wonderful material because we can use the entirety of this plant for different types of production. And what's interesting for us as architects is that we're really using this part of the plant, so the stem. And today this is actually a waste product that isn't that isn't used, that is burned, and actually it's part of the plant which is very interesting as a thermal insulator, and it's interesting once it is combined with this second material. So this is a lime quarry that we visited last year, because when we're working with these new materials or very old materials, but in any case materials that we're not particularly used to building with anymore, it's really important for us as architects to start understanding in a very profound way how these materials are made, the ways that they're produced, what are their limits, what are their potentialities, and part of that is going out and visiting the sites of production, speaking with those who are working with these materials, and so this is sort of kind of a work on the ground that we've been doing over the last few years. And when these two materials are combined, it creates hempcrete, and this is a microscopic view of the hempcrete, and we're looking at it under a microscope because when these two materials are combined, they create very specific hygrothermal properties. It's a semi-porous substance that allows water vapor to travel through a system of pores. And so we're trying to understand, it's a research project that we've been working with in partnership with the Université du Cervifel in Paris, trying to better understand these hydrothermic properties, the system of pores that exist within this material, and what it can offer in terms of level of comfort within the architectural project. And so again, looking really closely at these materials, it's going out to the production site, it's working with researchers, but it's also being present on the construction site. So I don't know if this is a subject for you in Estonia, but in any case in France, there's a real problematic tendency right now to evacuate architects from the construction site, and we think it's important that we hold this place in order to understand the construction of the buildings that we're designing. And so here we see the projection of the hempcrete. So hemp can be poured, it can be prefabricated, but in this case it is projected into the secondary timber framework that we saw earlier. And so again, it's this idea of enveloping a concrete structure where we try to use the least amount of concrete. So working with just a slab and post construction, and then this very thick insulating cover, which comes and envelops the totality of the building. And so again, this is a detail of the facade, and we see the ways in which working with the idea of thickness also starts projecting itself into the spaces, into the quality of the spaces we're creating, where the rooms are navigating within this thick facade to project themselves out at certain points, living spaces out towards the street, or recessing inwards towards the apartments. And if we go back to the construction site just a step, this is a zoom of hempcrete. This is what the hempcrete looks like sort of up close. And it's interesting to consider because in compared to other bio-sourced insulators, which is often sort of wool insulation, here we're working with the straw of the hemp straw, which when it's combined with the lime, it really gets suspended. Yeah, so the lime it solidifies, and the hemp fibers get suspended, and this is what is very interesting from an insulating point of view, because it traps air within the facade, but it also has qualities of inertia, which come from the use of lime. And so the presence of the air that is within within this insulating element is another idea that we find very, very, very interesting to consider. So we see here in this drawing, this is what we call 3 airs. And so we have the external air around the building. We have the quantity of air that we find within the envelope of the facade, and then the air within the internal spaces. And of course, all of these airs are sort of navigating around one another and communicating and participating in the creation of an internal climate and a level of comfort.
Yeah, and well, this idea of this consideration we wish to have to air is totally related to the idea of the boucher we were talking about at the beginning. At the boucher, let's say that the major concern was about mechanical charges and loads, and this was this fascination, you know, from the Gothic construction that led Viollet-le-Duc to understand very precisely how a load comes from the top to the bottom of a building. And we believe that today we should consider horizontal movements and trajectories of air, and how does the envelope, the B air, is giving power to the facade to regulate, and create inertia between the inside and the outside of a building. And following this consideration, then there are, of course, drawing is a huge tool to represent and to reconsider, the power of the air, and we wish to reconsider the air as something that architects should deal with, not only engineers, which have been the case for insulation so far, but we think that insulation is a new way to reconnect engineering to architectural, well, which was the case in the late, let's say, 19th century. But during the 20th century, maybe this is something that collapsed a little bit. And we believe that these two ways of looking at architecture, from engineering and architecture, thermal issues are a huge opportunity, again, to reconsider this negotiation. So this is how we represent, let's say, a facade and a plinth. So this is another way to represent it from the building Heather was talking about. So you can see the stucco, the insulation, handcrete, but so far insulation was represented like this. And then the 2 panels, Fermacell panels in the inside. Then you have here the concrete slab and pieces of wood that you were seeing on the axonometry view previously that hold, let's say, the handcrete together. But again, we can, reconsider the way we represent the thing and introduce the question of the air. This drawing represents porosity. So we bring and we start representing anything that is in the frame. Air, plaster, handcrete, Fermacell, and air, the inside slab. So we start saying that air is everywhere, but it's just this represents density. So density of the air, density of the stucco, density of the limestone, the handcrete, density of the concrete. So you can see the concrete gets a lot of power in the drawing. Then you can talk about conductivity, and this is something different. Porosity. So you can see that air becomes super strong in the drawing, and that handcrete loses its power in this matter of the word again, sorry. Yeah. Connectivity, sorry. And then this is temperature. So we were very interested in representing 2, several aspects of the materiality of the materials constitutive to a drawing. You can see that characteristics that we were saying on the previous drawings, but you also have phenomena that we want to represent, such as temperature in winter, for instance. And you can see that temperature of the air is giving a temperature to the facade, and then it slowly increases the temperature because of the insulation and the heating coming from the inside of the building. So this is again a way to participate to this idea of rationality, of rationalism, that kind of raised at the end of the 19th century. And in addition to the structural, because we don't say that we replace conductivity, effusivity, density, everything. We replace that I mean, this is not replacing charges and loads, but we believe that rationalism has to embrace another level of consideration, technical considerations related to the idea of the air. So that's, of course, to talk about comfort, because we want to, this is hemp all around, but we can still have large openings because of the availability to the envelope, to the thickness, to the fullness of the envelope, to manage relations between the inside and the outside, and to also raise the idea of the thick facade to the thick bow window, to the thick window, when thickness, fullness becomes something that sometimes you can inhibit within the apartments. And maybe as a conclusion, this is what we were saying at the very beginning during the presentation, this idea of natural materials is for us, rather than a statement, rather than something, it's of course something we believe in it a lot, of course, because we have to reduce drastically the amount of carbon from the building industry. But we also believe that this relation we have with natural materials is giving us a new role, in the world industry, let's say, as citizens of the world. And we believe that architects today are more and more doubting and trying to investigate and trying to find questions rather than answers. And this idea from practice to research to practice again is a state, for us at the office to always kind of try, investigate, experiment through the uses of materials. And we do researches. And then from that researches, we spread the words, we try to share our thinkings, our thoughts, and then back to practice again to try to do better, just like rationalism, just like the purpose of rationalism in the 19th century. So we do this research, for instance, that we lead for like a bit more than a year in Brussels about the transformation and the city fabric with the use of handcrete. So we selected pieces of Brussels and we try to say that, okay, transformations of building should reconsider, of course, it is based on the act of insulation, and this act of insulation is not only technical, but it could have some very important consequences on spaces, on language, on everything. So what does happen to Europe when it starts changing its buildings, considering these new considerations? So that's, for instance, two images. That's the first building that we will be, that site will start maybe in a bit more than a year in Brussels, that is using also insulation, handcrete, but with the application of brick. And the other one, just very quickly, is the transformation of a crèche, of a small school here in Brussels again, with a building that will use concrete and hemp on the facade.
Okay, let's give a raise applause to Thibault.